Good morning, all the participants. My name is RAJASEKHAR. Good morning, all the participants. My name is...
Sir, Rajasekhar, sir?
Can I start now?
Yes, sir. Can we start, sir? Can you able to ready with the PPT, sir, presentation?
You got my this one now?
Yes, sir. I got your screen, sir, but the PPT is not visible. You just showed.
Okay.
Yeah, sir. That.
You got the PPT?
Yeah, sir. It's 3D laser imaging.
Yeah, and just I'm sharing some videos also. Just I want to confirm.
Yes, sir.
Okay.
Okay, sir. So welcome you back for the session 2. So without further delay, let us start the session. I welcome Mr. Rajasekhar, General Manager, COACT Solution, Hyderabad. And he did his postgraduate diploma in instrumentation at Pondicherry University and BSc instrumentation from Andhra University at Visakhapatnam. He is a qualified instrumentation and electronics engineer with over 20 years of experience in service operation with reputed organization. He has ability to guide subordinates in rendering exceptional service and enhance customer satisfaction, and a keen planner with expertise in managing business operation with focus on achieving company's goals and mission. He is an enterprising leader with exceptional planning, organizational, and interpersonal skills. He had traveled globally over 25 countries and had global experience in transportation engineering and civil engineering category. I welcome you, sir. I just hand over the session to deliver your topic on modern equipment for payment evaluation.
Good morning, all the participants. My name is RAJASEKHAR. I'm from COACT Solutions. Thank you for giving me this opportunity to present modern equipment for the payment condition service. We are representing Whaling Systems Corporation.
Sir, excuse me, sir. Sorry for the interruption. Just one suggestion, sir. Can you press on the hide icon on your screen, sir, so that the PPT. Yeah, sir. Fine. Thank you.
We're representing almost 30 years, Dr. Kelvin C.P. Wang from the Regency Professor from Oklahoma State University. And we have 30 years experience to develop the instrumentation from Whaling Systems Corporation, USA. We have our own sub-M 3D laser imaging sensors and future of payment condition surveys. And also today I'm discussing with functional and structural evolution for the long-term preventive maintenance for the network survey vehicle, polymer deflectometer, and ATCC, automatic traffic counting and classifications, and some introduction about road asset management with complete day planning, yeah, artificial intelligence based. So from sub-mm sensors to comprehensive solutions present in the market, we have current domination resolution measuring 3D sensors of 3 mm, 1 mm to 3 mm. So first we have introducing in the worldwide market 0.5 mm 3D laser imaging. I can explain you what is the use of 0.5 mm 3D laser imaging system in the next 5 to 10 years generation for the payment condition surveys. And 0.1 mm 3D laser imaging for the safety. So why we want to use 0.1 mm 3D laser imaging for the safety? I will show you some of the slides and videos. And next 5 to 10 years, we have deep learning in the fourth year, the future for fully automated distress surveys and surface characteristics. Present in the market, we have three 3D laser profile systems, but we have to do manually the payment distresses, and some softwares are taking long time. If you collect 200 kilometers data, it's taking almost 1 week to 10 days to process the data. So current application of 3D imaging system is one of the first generation vehicle in US. And we have supplied to different countries like Brazil, Mexico, and Japan and China, and integrated with some rolling weight falling deflectometers. And sample 3D data at 1 mm resolution collected at 60 miles per hour 10 years ago. 10 years ago, we use DSDV technology before deep. Now present technology is deep learning, artificial intelligence based. Before that, we called DSDV. So this is the software. We can see the 43.4 mm depth, longitudinal and transverse, and corresponding to the video image with pothole graph bottom. So sample 3D at 1 mm resolution collected at 60 miles per hour 10 years ago. This is a crack depth, almost to pothole depth 44.2 mm, corresponding to the graph. And sample 3D of example data at 1 mm resolution collected at 60 miles per hour 10 years ago, 44.2 mm. So we called PAVE 3D AK the next
Hello?
generation. Yes, ma'am.
1 second, sir. Sorry for the interruption again. So, can you make it as a full screen or fit to the screen as full?
Yeah, you can see, ma'am, because this is okay, ma'am. This is small one. I have some. This is a PDF format, ma'am.
PDF, yes, sir, that I can understand. But this is a suggestion from the participant, so that only I asked. I can understand, sir. But it's okay, sir. You can continue, sir. No problem.
Sorry.
Yeah, no, you can continue, sir.
So this is we call model PAVE 3D AK, the next generation 3D imaging system. We have more than 8,000 pixels in 2D and 3D in the transverse direction, covering full line width of 4 meters. We use 30 to 30 kilohertz line rate in the longitudinal direction with 1 mm longitudinal resolution at 60 miles per hour. Compatible with current deep learning solutions, built-in inertial sensor for longitudinal profiling as well as road geometry. And we have the processing software for cracking, retting, patching, potholes, and seal cracks with artificial intelligence and IRI, International Roughness Index, and BA values. Also, we get road geometry automatically with single sensor. So basically, you can see the image PV3D 8K in the truck mounted. You can mount it to any SUV. This is the two lasers to cover width of 4 meters. So single laser can give roughness, rutting, texture, mean profile depth, and mean texture depth, as well as payment distances. So this is a Pave 3D. It is a single sensor which can give IRI, roughness, texture, and all the pavement distresses other than the road inventory. So this is a sample data of manual full line 2D image collected from this sensor. Sample data of manual collected from 2D and 3D data. Left one is 2D image and right side is 3D image. Sample data of manual zoomed in 2D. Light reflector full line width, one of the example of the image. Light reflector zoomed in 2D. Light reflector zoomed in 3D. So why we need 0.1 mm 3D laser imaging for the safety? So now we have come in the worldwide market with 0.1 mm 3D laser. That means we are measuring the sensor with 0.1 mm. The micro and micro texture will be 0.5 to 50 mm. The sensor can measure from below 0.5 mm. We can get every 1 centimeter. We'll get the skid resistance for the road safety. Earlier we are using for the pavement safety. We have micro macro texture. Micro and micro texture starts from 0.5 to 50 mm for the friction correlations from the texture, like from mean profile depth and mean texture depth. But our sensor can measure below 0.1 mm. So we can get continuous skid resistance like good, fair, or bad as for the ASTM standards. We are coming with January. Current contact-based friction testers are available. Decade, very old standards, contact with water, tire wear, and large variations, consistency and repeatability. Because present methods we are using to measure the friction, we need a bigger water tank and we need to have a truck to drive. But now we developed the sensor of 0.1 mm which can measure 0.1 mm resolution. So we can measure every 1 centimeter the skid resistance values. And 0.1 mm non-contact approach, possible critical protocols and processing methods. This sample of 0.1 mm 3D pavement surface. One of the sample image 0.3 mm. Sample of 0.1 mm 3D pavement surface. So how once the sensor measures the raw data, we use artificial intelligence analysis based on deep learning. In the world, we have done almost 30 years R&D with the large number of data images with artificial intelligence based deep learning. So learning database critical for learning. This is one of the example. This is a machine learning completely. So how the artificial intelligence software is built, we call CrackNet. From training to operations, we put input images. We have lost 30 years database of collections from the payment distresses from various payments, and we put it in ground truth with pixel perfect accuracy with the DL network, then recursive training, then detection of output with pixel level accuracy. So pixel level intelligence is some of the images. You can see automated pixel level pavement crack detection on 3D asphalt surfaces with a recurrent neutral. So these are all the software algorithms. So first we use first generation CrackNet. We put input image 512 into 1024 resolution into the feature extractor, then put it in input layer, then fully connected layer 1. Then we use convolution layer 1, then we use fully connected layer 2, convolution layer 2, and output layer. So we have 7 layers out of taking the parameters of 11,59,561 parameters. So development of CrackNet, we use some CrackNet and Crack2, Crack4, and now present we use CrackNet R. This is used for automated pixel level pavement crack detection on 3D asphalt surface with a recurrent neutral network. Present we using CrackNet R. Some of the sample results of first generation CrackNet. The left side we shows the images. Samples of second generation CrackNet, best CrackNet plus RNN. So CrackNet on concrete pavements, non-grooved joint surfaces and grooved joint surfaces. These are all some of the images collected from our sensor and software. Recent development of CrackNets. So you can see we have developed with CrackNet R some of the sample images. Earlier we told in the previous section we have seen we required long-lasting payments for deterioration rate. We have talked about rutting and cracking. Also some other parameters like shoving and traveling. So we are doing for functional data collections with 3D sensor. This is complete automatic. Once the presentation is completed, I'm showing the video. Other crack features like markings can identify automatically, manuals can identify automatically, bridge expansion joints. These are some of the examples. And expansion joint detections, accuracy with 93% with a processing speed of 50 miles per hour. So this is a deep learning based marking identifications. It is completely automatic. We can identify the marking identifications automatically. So pothole identification, the software called ADA, Asphalt Automatic Distress Analyzer, which can do automatically calculations for pothole identifications, crack, different types of cracks, traveling and shoving and everything. So pavement patch detection. So we tested with 20,000 manually animated sample images and we put it in the deep learning for semantic segmentation with pixel level accuracy. Earlier we used crack 1 and crack 2 softwares, methodologies. We use 84.58 with a processing speed of 60 miles per hour. And some of the pavement patches detection automatically, because ADA software can detect automatically the patch detections. So patching identifications is automatic. Some of the images of patching identification. Seal cracking identification, wherever you've done the seal cracks, it identifies automatically the seal crackings also with our software ADA. Sealed, this is some of the images of sealed crack detections. Left side is 2D and right side is 3D. Seal cracking detection, we have improved with crack or network analysis system with 3,500 manually animated sample images, deep learning for semantic segmentation, pixel level accuracy. We got 85.04% processing speed of 60 miles per hour. So manual detection accuracy is greater than 80%, processing speed at 80 miles per hour. Now present we are using crack or with the speed of 100 miles per hour. We are almost reaching 95 to 97% accuracy with the manually animated and automatic distance calculations. Faulting detection joints first. This is one of the slides of faulting detection joints with 2D and 3D images. So fault detection, it is in longitudinal direction as well as transverse directions. It can identify the cracks automatically. Some of the sample images. So fault detection, pavement joint detection via deep neutral network. We use 3,000 manually animated sample size. Accuracy we found 85% at processing speed of 60 miles per hour. Some of the images. So cracknet, multiple distress dissections, pixel level accuracy, diverse training data, deep neutral networks, parallel computing, efficiency, non-cracking distresses, real-time processing, constant accuracy, precision bias better than 90%. Why we are going for artificial intelligence deep learning for the processing the data? Because in the present market, we have so many 3D sensors of systems. Once the survey data is collected 100 or 200 kilometers, to process the payment distress data is taking almost 1 week to 10 days. But Whaling Corporation, we have vast experience, 30 years experience in the worldwide market for deep learning artificial intelligence based. Our processing speed is 100 to 130 miles per hour. Once we collect the data of 200 kilometers, within 45 minutes, all the parameters can be collected and it can be uploaded to web-based system or 5G or cloud-based. So recent development of CrackNet, increased number of manual animated sample sizes, more than 20K images, because we are doing research from last 30 years. We have long database. We use deep learning networks, improved architecture-based advanced models. Accuracy, CrackNet, earlier up to 2019, we have 91.84. Now using CrackNet R, we are reaching almost new CrackNet 96.12%. With the processing speed of the ADA with the CrackNet R, 12 miles per hour or 71 miles per hour. Now we have achieved 100 miles per hour. And data augmentation via one of the example how generative models, the methodologies, and data augmentation via generative models, lab, original image, and artificial intelligence generated via the first blue color shows the lab, and second one is the original image. So artificial image generated via generative networks. We call it GANs. Noise reduction by GANs. We have original image, add and noise. Again, we give ground truth, and finally the network output generated through the artificial intelligence is the original image. Noise reduction by GANs, because left side you can see the real-time 3D images, output images filtered by GANs for reducing the noise reduction by doing the noise reduction by GANs, applying the GANs. The deep learning based texture and data analysis, we have 1D raw texture profiles from the 3D sensor. We do the data preparations, the feature abstractions from average pooling and average pooling methodology, and we do the classification by friction number. Because here the sensor is measuring below micro texture, that means below 0.5 mm, that means 0.5 mm accuracy. If we can measure 0.2, 0.3, 0.4 accuracy, then with our texture SMTD, what we call MPD and MTD, we can put our skid resistance for the road safety, good, fair or bad. Recently we are developing the ASTM standard. The new ASTM standard is releasing in January. And we are putting the output friction levels from 0.2 to 1 mm, 1 and 0.1 interval. Means even 1.1 mm interval, we can measure the skid resistance using our 3D sensor. Deep learning based texture data analysis, small graph, number of rounds, 0 to 350, and y-axis is accuracy. Almost we compared with wet type water-based friction testers, as well as 3D sensors, we found accuracy 88%. Present, we are almost met 95 to 97%. Automated surface type classifications, one of the example, 2D pavement image, input layer, and feature abstractions, and the classification predicted by a pavement type, AC, CRCP or JRCP, output layer, and input 2D pavement image, output predicted PD type. And automated surface type classifications, we have a number of epochs and classification accuracy on the y-axis and cross entropy loss. So we met almost 98% automated surface type classifications. So we have 3D sensors for the next generation from 0.1 mm to 0.5 mm 3D data. Next generation will be next 10 years. We use deep learning, artificial intelligence based, comprehensive condition, function, and safety using the same sensor, and same data can be uploaded by 5G or cloud based, computing in any platforms and most critical solutions to all the users. So I'm showing some software analysis data collected from this small demo. So basically this will be used in Oklahoma University. Backside you can see two sensors which can cover 4 meters width. So basically this is a 3D sensor which have 30 kilowatts. Generally we use for IRI, International Road Roughnecks, or BA values for the longitudinal profile. And this sensor has built-in IMU, so we can get horizontal curvature, gradient, and cross slope. And also it's have 30 kilowatts, so we can measure the texture like MPD and MTD, mean profile depth, and mean texture depth, as well as pavement distresses with 2D and 3D. It's have built-in cameras as well as 3D laser sensor with 0.1 mm accuracy. So this is completely mounted in the Indian vehicle, US vehicle in Ford. We have a built-in DGPS, differential GPS. So just how we collect the data collection, we are collecting the data at 100 miles per hour. So while doing on survey, it will be a single line. It will cover single line of 4 meters. Right side, you can see the camera that is for road inventory, which can covers 180 degrees of 2 cameras, 90 degrees. So you will get complete road inventory as well as 2D and 3D images. Because this software completely artificial intelligence based, while collecting the data itself, it will do the calculations. It will can identify all types of cracks, and it shows the real time on the display. It shows the distance, sub distance, GPS coordinates, as well as real time IRI, real time texture, real time rating, all the payment distances. We can collect the data at 100 miles per hour. This is the real time data, so you can collect it at 100 miles per hour. So once the data is collected, I started at 10 o'clock and I collected all the data. I completed at 2 o'clock. Then inside the vehicle, within 35 minutes, I can process 200 kilometers data with a real-time 3D image and real-time crack detections. It can show us what type of the cracks. It's a transverse cracks, it's alligator cracks, or it's any types of crack, longitudinal cracks. It can identify automatically. We can see the left side. It shows the IMU GPS, latitude, longitudinal. We get cameras for the road inventory for 180 degrees view. So bottom, it will calculates automatically all types of cracks. Everything is automatic. From February onwards, we are doing not only cracks, seal cracks, rutting, roughness, bleeding, shoving, raveling. Everything is automatic. We don't do any manual intervention. We are saving a lot of time, because earlier Dr. Veeraraghvan sir had told to me that we need a preventive maintenance based on the rutting and raveling and everything. So in the preventive maintenance, we can identify all these before itself by calculating the deterioration model and keeping the data in a road asset management. It will be a great asset. We are saving a lot of money for the maintenance. We can save a lot of money in that. So we have providing along with what we called earlier ADA, data analysis in automatic distress analyzer 3D. So this is the raw data collected in MDB format. So once the data is transferred to automatic distress analyzer, we have a lot of options in left side: auto detecting line marks, auto detecting gen markers, auto detecting a faulting, auto detecting pothole, auto detect of patches, auto detect of seal cracks, auto detect of multi objects. We can do manual classifications, because all these softwares are made according to ASTO. Because we follow longitudinal profile calculations, we follow ASTM 910. For the payment distress, we follow ASTM D6433, and also we incorporating as for the Indian conditions IRC 82 and IRC 32 as for our payment distresses. We are tuning to according to the IRC standards. And we have readily available PCA calculations as for the ASTO standards. It is readily available in the software ADA. You can see the right side, lot of images collected, 2D and 3D. We have a crack box here, right side, and crack map. You can select it, whatever the parameters required, line markings, gen marking, do crack, do rutting, profiler or texture or bumping. This is used for airport fields where we call Boeing bump index. You can select pothole or patch or seal cracks, do wear or group cracking, and report. So 200 kilometers data can be processed within 40 to 45 minutes. So this is completely DL based automatic crack detection, artificial intelligence based. detecting the line markings and everything automatically, detecting general markers, analyzing the cracks. You can see the right side corner, the processing speed is 127 miles per hour. The complete 200 kilometers data can be processed within 40-45 minutes. Everything is automatic. It will shows once the process the data, you can see left rutting, right rut. It can give the rut depth as well as rut width with Chinese. You can see the left side Chinese. So detected cracks. You can see the crack, longitudinal crack or transverse crack. Automatically, it identifies. So you can see here the alligator crack. You can see the transverse crack. You can give the crack depth as well as crack width and percentage of severity in the reports. Here we have a lot of options for international roughness, rutting, pothole, and row camera enabled GPU. We have road geometry because already it's have IMU, universal sensors. So this is identified left and right road markings automatically. You can see the right side image corresponding the 3D image also shows on the left side window. So automatic line marking identification, it's taking considering, and it covers 4 meters complete width. And left side, you can see the Chinese. So we are processing the rutting. You can see the left rutting and right wheel path rutting, 3.2, 5.3. And you can see the bottom, there is a graph correspondingly. And also we are providing as for ASTER standards or wheel path, 3 options are provided. You can see the with the frame number with the Chinese, you'll get it left rutting, right rutting. You can see the cross slope, gradient automatically, road geometry. And we'll get a, based on the road geometry, we'll get a number of rise and falls, everything. So these are all the options, right side. And we have UK scanner methodology, just you can select same frame. According to UK scanner, it will process automatically. UK scanner is one of the methodology for the crack. You can export to final to any format. And we are processing the data with ASTO R85. Same thing we have already tuned to IRC 82 and IRC 32. We are under process. So it's calculating as for ASTO distress analysis. So automatically it gives a report of crack weight, crack length, and density and crack area automatically. There is no manual intervention. And you can export to any format. And once it will be there, we have already inbuilt PCI as for ASTM D6433. It calculates automatically the PCI number, 0 to 100 scale. Once data is processed, it gives automatically processed MPD of the both the wheel paths, mean profile depth, as well as MTD, mean texture depth. See, every point with the georeferencing, you can see the MPD and MTD values. Every 10 meters, we can select it our processing interval, like 5 meters, 10 meters, or 100 meters. And also we provide pavement roughness analysis using the same 3D sensor. Even we provide BA values both. So this is left IRI and right IRI. Export to any format like CSV or HDM4. We export to HDM4, Highway Development Management 4. And also automatically identifies the automatic seal cracks. Is detecting seal cracks automatically. The software built with completely deep learning, AI based. So this is the seal cracks identified automatically. So length, block area and everything. And we are providing data review and multimedia highway information system for the final reporting. In the final report, once the data is exported to MHIS software, we can see longitudinal cracks, transverse cracks, alligator cracks with each signage. And also it gives the friction values, friction plot and crack, 3D crack, everything. In the top, we can see the 3D image clearly, corresponding the row image. Three D image rotation. And we get every point, we get lat long and longitudinal for geotagging, georeferencing. And we have a Google map, Google data route map. Wherever you select that map, automatically it shows on the route. Here it shows 1 alligator crack, 2 transverse crack, 3 longitudinal crack. You can see the bottom of the corner, it shows the route. It's satellite image. So all the parameters like payment condition surveys and payment distresses, we do automatically. So this is a 3D image on the bottom, on the top. So this is complete vehicle. This system is available from March 1st onwards on Indian highways. From next year, from March. So next presentation, I'm going to for falling weight deflectometer for the structural analysis. So once functional is completed, then as for IRC 115/2014, we know the rating of 100 kilometers, then roughness and cracks and everything. Then we can collect with structural analysis by using falling weight deflectometers. So payments deteriorate over time and requires regular maintenance. And strengthening is a type of maintenance activity to increase the structural capacity of the pavement. Strengthening involves providing an additional layer of bituminous coats over an existing pavement. The thickness of the additional layer is determined through deflection survey. Deflection survey is done to determine structural capacity. So introduction, deflection survey. We have earlier, before 2014, everybody familiar with Benkelman beam deflectometer, BBD, as for IRC 81. Now from IRC 115 from 2014, we have called falling wedge deflectometer. For flexible payments, we use IRC guidelines or IRC 115, and rigid payments, we use IRC 117. So FWD deflection survey. So small introduction. Overlay design was initially performed using Benkelman beam deflectometer, BBD we call. In BBD, static load is used to determine deflection and is more labor intensive. If it is a single line, we have to stop the traffic. BBD method was developed considering thin pavement layers such as bituminous macadam and premix carpet. The current pavements are thicker and have superior layers such as dense bituminous macadam and bituminous concrete. Most importantly, pavement in field encounter dynamic and repetitive loads. Introduction. Green one is pavement 1, pavement 2, and pavement 3. Structural evolution of pavement has been improved considerably. Impulse loading equipment are used to simulate dynamic loads. Falling wedge deflectometer FWD impulse type loading equipment. Load dropped from certain height and deflection is measured. As for IRC 115 2014 is the guidelines for the structural evolution of flexible pavement using FWD. For the flexible pavements, we use 40 kilonewtons with 9 geophones or 7 geophones. For the rigid pavements, we use 70 kilonewtons load. If the concrete thickness is more, we use up to 90 kilonewtons load with pulse time of 20 to 30 milliseconds. So principle of FWD, we have a mass of more than 600 kgs and we put 9 geophones. Center geophone is D0 and we have a base plate of 300 mm and D1 to D8 to up to the beam of 1.8 meters. With a pulse time of 20 to 30 milliseconds, you can see the rise time. Once the weight is fallen down, it can give the pulse duration. The pulse duration should be, as per the IRC guideline, should be 20 to 30 milliseconds. So types of FWD, we have in-vehicle FWD and trailer mounted or towing type FWDs available in the market. So deflection measurements, testing plan, determining the number of deflections and interval of data collections. So this is a formula n is equal to z into cv square by r square. Coefficient of variations, good section 15%, fair section 30%, and poor section is 45%. So number of deflections, good section will taken at 95% confidence level, that is equal to n is equal to 25 samples, one of the example, and 90% confidence level, n is equal to 4 samples. If it is fair sections, we take 95% confidence level at 98 samples, and 90% confidence level, n is 15 samples. Poor sections, we take 95% confidence level at 221 samples, 90% confidence level will take 33 samples. So correspondingly, the interval of measurement, if the good section, we take 95% confidence level at interval of 40. If 90% confidence level, we take every interval of 250 meters. So fair section is similarly 10 meters and 67 meters, and poor section at 5 meters and 30 meters. So deflection measurements, deflections are measured at the wheel paths. The FWD is positioned at the location where deflection has to be measured. The loading plate is lowered at the point of deflection measurements. Frame holding the sensors, geophones is lowered and brought in contact with pavement surface. Mass is raised and dropped on the loading plate to check the value of the load test drop. After test drop, load is dropped 3 times and the deflection is recorded. So once presentation is completed, I'll show some videos. So deflection measurements. So a test pit is made at every 500 meters in staggered manner to determine the thickness of the existing pavement crust to know the crust thickness of the different layers. Analysis of data. Data analysis includes identification of homogeneous sections. When we collecting the data, it's very, very important because already we taken with functionals. like rutting, roughness, cracks using NSV, and data analysis includes identification of homogeneous sections, back calculation of layer model, applying correction for temperatures, applying corrections for seasonal variations, then determining the remaining life of pavement. So analysis of data, homogeneous sections are identified using cumulative difference approach, we call CDA, and surface curvature index, we call SCA, and other parameters. Like you can check a Chinese of 0 to 9 kilometers, and we can see y-axis is cumulative difference. Similarly, we can see the base on thickness, x-axis Chinese of 0 to 9 kilometers. You can see y-axis cumulative difference. Analysis of data, layer model is back calculated based on the deflection obtained from FWD. Thickness of different layers of existing pavement. Crust is required to back calculate. We required crust thickness to calculate the required back calculations. There are several applications which can back calculate modulus using deflections. As for IRC 115 2014 recommends to use the KZP back to determine the back calculate modulus, and KZP back works on the principle of genetic algorithm. Analysis of data, seed modular range, if it is good, that is BT surface 750 to 3000 megapascals. Granule, it is 100 to 500 megapascals. Subgrade, it's 200 to 100 megapascals. Fair and poor, BT is 400 to 1500 megapascals. Granule, 100 to 500 megapascals. Subgrade, it will be 22 megapascals. These are the guidelines given in IRC 115 2014. Assume of section to be fair. Suppose we are assuming that section is fair. So that one 80 mm bituminous layer, the Young modulus will be 400 to 1500 megapascal. If it is L2 layer 2, that is 380 mm, that is granular layer, then Young modulus should be 100 to 500 megapascals. L3, that is subgrade, the Young modulus should be 200 to 100 megapascals. For the deflections, earlier we have shown in the slide, we have 9 geoforms from covers from 0 to 1.8 meters. The first geoform, the deflection is 0.6016 mm and 0.3615. Last geoform at 1.8 is 0.414 microns. So this is some empirical formula for analysis of data with the seed values L1, L2 and L3. Analysis of data based on the deflections from D0 to D9, root mean square velocity, that is 0.0191 mm. So this is a sensor number 0 to 8, and this is deflections in mm. Analysis of data, we do normalizing all the deflections and load at 35 degrees. This is considered to be standard pavement temperature. Field pavement temperature higher than 35 degrees results in lower back calculated modulus, it will be affected. So we normalize to 35 degrees centigrade, all the parameters like field pavement temperature lower than 35 degrees result in higher back calculated modulus. So this is the empirical formula, ET1 and lambda, and T1 is equal to 35 degrees centigrade, T2 is field pavement temperatures. Analysis data as for the IRC 115-2014, seasonal moisture corrections factor is applied to determine the modulus considering the worst subgrade conditions. Subgrade gets weakest when it is wet post monsoon. Moisture correction is applied for granular and subgrade modulus as for the KGP or IRC guidelines 2014. Analysis of data for a given homogeneous section, number of modulus values for each layer are back calculated. For each layer and for a given homogeneous section, we calculate 15 percentile moduli for each layer is determined as representative moduli for that layer. We can see BT modulus and megapascal and granular layer and subgrade for the 15th percentile. So x-axis is percentile and y-axis is bituminous modulus in megapascal. Analysis of data as 15th moduli is determined for each layer corresponding to each homogeneous section. Moduli and thickness are fed in IIT PAVE analysis software to determine the rutting and fatigue strains calculated in IIT PAVE. Rutting and fatigue strains are used to determine the remaining life using the formula NF is equal to 0.711 and NR is equal to 1.41 for the remaining life for fatting, rutting and fatting. The final analysis of data, Tableau format, we get 15 percentile of bituminous modulus, granule modulus, and submodulus in first three columns. And bituminous layer thickness, we entered 90. Granule will be in the first row. Bituminous layer thickness is 90 and granule layer thickness is 373. Then it calculates in the IIT PAVE the tensile strain and rutting strain and fatigue life in million standard axles, fatigue life and rutting life in MSA. So this is one of the slides shows example of designing traffic for overlay of 50 MSA. Allowable fatigue strain is 198.474 microns. Allowable rutting strain is 370.694 microns. Pavement is model has 4-layer system to find overlay thickness. So this is IIT PAVE software, KGP, analysis of data. We select number of layers 4. Layer 1, layer 2, layer 4, the elastic modulus. And we give each material poisonous ratio 0.35, 0.5, 0.4 and 0.4. And we entered BT and granular and subbase thicknesses 90, 93, 73. And we entered the wheel load of newtons like 20,000 newtons and tire pressure 0.56. We do the analysis 0.4. Again, we entered a depth of 4 and will give the radial distances. Then it calculates the critical fatigue strain and rutting strain in the software, IDPAVE. So also we have, I'm showing some videos. Sorry. This is a vehicle we are calibrating all the geophones as for Astro R32, all the geophones of 9 geophones. This is recently we have supplied to Kerala, Kirby, Kerala Infrastructure Board for vehicle mounted FWD. So bottom you can see the plate of 300 mm with the built-in load cell and geophone, and we have 8 geophones, remaining 8 geophones from D0 to D8 from the 1.8 meters beam. So this is the beam length of 1.8 meters with IRC guidelines like 200. All geophones are installed 200, 300, 450, 600, 900, 1500, and 1800. So this is a complete hydraulic system which can latch, which can lift the load. So we called 4 drops. First drop will be settlement drop. Again, we put 3 drops, that is sample drops. So this is a complete vehicle mounted in Tata Winger BS6. You can see the complete loading frame and electronics is inbuilt. We do absolute calibration because in IRC 115-2014 it is clearly told we have to do the absolute calibration where the deflection is 250 to 600 microns. The variation of all the geophones should not be less than 4 microns. So we are doing the stack tower. We're putting all the geophones, which should reading within the limits. I'm showing one more video which can give. So this is operation of van mounted FWD. It's have weights of 350 kgs. Then we can drop it. We get the pulse time of 20 to 30 milliseconds. We can adjust the height. As for IRC guidelines, the height should be 100 to 600 mm. So this is the completely vehicle mounted. The first time in India we supplied to South India in Kerala. Once deflections are stored, we do with IIT Pave the analysis software. So bottom we have a inbuilt load cell as well as geophone, and we have 9 geophones within the vehicle. This is a distance sensor which can give the Chinese. So this is a completely 300 mm plate. And so I'm showing the graph, the result how shows in the software. You can see the Chinese as well as coordinates. We can see the force in 40 kilonewtons, the corresponding pressure we can see, and we can see the D1 to D9 deflections. First deflection 3, we got 4 drops. First one is the settlement drop, and remaining 3 are sample drops. We can see the deflection D1, D2 to D9, and we can tease the pulse time. And bottom it shows the historical graph, the load versus all the geophones, and it reads total 3 temperatures. One is surface temperature, ambient temperature, as well as manual temperature. We take manually. And the advantage is now we have a complete calibration kit on site, calibration for load cell and geophone on site. This is one of the images of load cell, and we have our own geophones, so we do calibration on field for load cell and geophones as well as temperatures. So this is completely about structural analysis for van mounted FWD, and we have tie-up with COSAI, is a Madurai based company. We do ATCC, automatic traffic and counting classifications on AI based. So about our company and vision, we develop artificial intelligence according to our road Indian conditions. So we have ATCC as well as automated ANPR, automatic number plate recognition system, and video-based parking management system, complete things, as well as traffic flow analysis, detection of moving violations. So we have artificial intelligence-based automatic traffic counter and classifier as for IRC guidelines. So why ATCC using AI-based is not much popular in India. Only very limited companies are developed. So we have a key features of AI-based. It's completely AI-based. We use free flow traffic count and classification operates 24/7. We do 24/7 traffic counting classification automatically. Within 10 meters interval, we can send the directly data to your cloud base and cover up to 4 line of traffic. Neutral network based classification. Again, we use CAN network, fully customizable reporting system to meet unique business requirements. We do parallel vehicles detection. We do bidirectional vehicle detection, either from left or right side. Low false classifications rate. And advantage is we developed all the softwares in India. So we tuned according to the Indian conditions. High accuracy level of 95 to 98%, either traffic count and vehicle classifications. A complete IP video-based solution, mobile and non-intrusive solutions. And we do real-time video analysis, highly costly effective solutions, easy validation of traffic data, and easy integration with third-party software. The principal process of workflow, we have a solar panels, battery, and power. We have cameras which can recognize, record the real-time video as well as automatic number plate system. We have switches and VPN root firewall, and we are continuous recording the data. And we have edge devices, and from the cloud VPN we can connect it to your firewalls, and we can use our own server to record the data. So basically you can see the flow chart. It's a video record, video frame, label animation, training, testing, vehicles counting, generating the output, final output. So we have a lot of challenges in the national highways or state highways, because we don't use existing poles of NHA or state highways assets. We use our own poles, manually can be lifted up, and we mount our own video cameras. If it is bidirectional, we use 30 meters and 50 meters to identify the vehicles, 2 lines with the 2 cameras with complete power supplies with our systems. So this is one of our screenshot. We have almost 33 classifications because we are developed the software in India. So we can do according to customization of the classifications according to the client. We follow as per the IRC guidelines. Auditing and report model with a date, timestamp. So we do a lot of surveys, also pedestrian counts, bicycle counts, customizer counts, traffic analysis, traffic violation, automatic number plate recognition, smart parking system. And I want to show you some video. We process one data. This is a sample video which is collected with AI based. It's do automatically classifications. We have 13 classifications. We are collected at the toll plaza. This. And the data with the real time can be pushed to cloud within 10 to 15 minutes with complete report. The advantage is, suppose we are doing it at one toll plaza, suppose our accuracy is 95%. So we take 1 day sample data and we tune to meet exactly 99 to 100%, because all the classifications and everything can be done within 1-2 hours. It gives a speed also automatically recorded, speed also provided in the report. So we can customize according to client's requirement. So we can give the report like hour basis, day basis. We can split it to according to this web-based solution. So once the data is collected, where we are keeping the data saferly. Suppose we have collected every 6 months, we collected with the data with FWD and NSV. So are we keeping the data in a safer side? or the deterioration rate is calculated, because until unless we keep the data in a safer side like and references, then only we can calculate either preventive maintenance or long-term lasting. So we represent Laundrix Limited. Laundrix is a New Zealand-based company who can having a linear platform for the keeping all the data, images, video in a safer site to calculate the financial modeling. We have GeoViewer data elements. We have a road condition data because we're collecting with the 3D data like rutting, roughness, cracking, and all the payment distresses with the PCI calculations and everything. So manual inspections. We have photos, videos. For photos, we have road inventory processing software. We have all the assets can be processed, and all videos, all event accident data, and inventory like bridges and signages. These are all assets. And maintenance, reseal or rehabilitations. Last presentation, Dr. Veeraraghvan sir told me that we need a preventive maintenance. Whatever preventive maintenance has to take, and how the financial model will be calculated. Until unless we will not keep the data in a safer side, we cannot do certain things. So these are future works. So bridge the gap with the technology. We have integrated all the modules like bridge module, like asset module and everything. Analyze the data and make decisions. Once we have all the data in a road asset management, then we can take a good decisions. Like customized systems, this is a framework how the software is built in. This is a customized system and frame network. We have a centralized elastic data valued web and data server technology. We does have data engine. We have offline and smartphone applications. We have core engineering tools. We have admin tools. We have GS tools, statics tools. We have forecast module, graphics, and we have customized fit for purpose of asset management with all these modules. So we have a cloud-based application engine, database server, application server, video streaming, user one, user two. Whatever data is collected from functional and structural, we can keep it in cloud-based. We have offline tools and online. So we recommend to highway authorities, city councils like local government and contractors to keep the data in safer side for the future calculation, and toll roads, rail authorities. These are all some of our customers. So small video on GeoViewer. So here you can see the screen. It's a linear platform. It will accept any company's data, either it is NSV or FWD. What we do is once we collect the data, we process the data, we can upload into the web-based system. We can see the videos can be uploaded, images can be uploaded with the GIS tools. We can see the left side IRA roughness. This is the strip chart. So we can play the particular road asset network video. Then automatically we can see the what is the IRA values, what is the rutting, what is the cracking with the Chineses and everything on the GS tools. We can see the full screen mode. Whatever data collected from 3D sensors, just upload the data. You can see the video. You'll get very comfortable strip chart maps, very friendly user. At a time, you can view multiple videos, either payment distress or road desert or any videos. We can see the left side corner, we can see rut, depth, NASAR accounts or roughness or BA values or anything. So once we collect on the GIS tools, if we click it, that particular image will be opened, and so it can shows in the single screen, you can see all the data like payment distresses, accident data, surfacing, photos, videos with different colors with strip charts. Suppose once we have collected with NSV and FWD data, based on the data, we can show different types of different colors with the surface treatment, and we can put it every 6 months data and overlapped. It will be asset to the NHA or contractors or any contractor, so that it's more easy to take a decision maker, which has to be taken a preventive maintenance based on certain parameters like roughness, rutting, cracking, and the payment distribution. It will be more easy to the contractor and the other users to decide as a financial modeling and funding. And so each one will get a GS tools. We can see online. We can put it condition data, whatever the payment condition data can be uploaded, completed works, assets, network events, and field information. And it's very easy strip chart because it is very easy to click it. You will get all the details for the forecasting. As for HDM4, financial modeling also we can do it. This is a forecast modeling. We can see all the parameters with the strip chart. And bottom it can give the total length of the treatments and funding and everything. And once we collect the data of every 6 months, 1 year, or 2 years, so we know the last 1 year what is the data of payment condition index and all other parameters. Then we put it again, we repeat it second year, third year. The repeatable data can be overlapped, and we can make a deterioration module. What may be the changes, either it will be environmental, either it is a rutting or payment or cracks. We can identify very easily, and we can maintain that particular stretches easily by maintenance. Preventive maintenance can be taken care. Once we have all the data of every year, so just you can click it. We are put it in a server side in road asset management. Then we click it that particular year. It will do the comparison. And the street map view, it will compare with multiple parameters with multiple view. These are trend graphs with selected lengths. It generates automatically report. We can generate large number of sites reports automatically. And we provide offline. We can download or upload in offline applications. All the parameters can be available in our mobile offline mode. So once everything is available in the web base, you can take it over offline. You can see what is the condition of that particular payment at site itself. We can see all the road assets like drainage or signage or anything over a period. Wherever you click it, you will get all the parameters. It's in the hand. So we provide all offline apps. We can download the data from your website, web-based system. Offline and online, both can be done in. Thank you, sir. So with this one, I completing my presentation and video, sir. Thank you. Any questions you can ask me.
Thank you very much, sir. Rajashekhar, sir, thank you very much. Excellent presentation. I was watching it. Thanks a lot. I'll be in touch with you. Actually, sir, it's the area of my interest. I'll be in touch with you. Thank you, sir.
Thank you, sir.
Sir, audience, you can ask questions. Shobana, take the mic and carry on.
Yeah, sir. Thank you, sir. So, participant, you have any question, you can just post your question in the chat box, or even you can unmute your mic and you can directly ask to Rajasekhar, sir.
So
Sir,
Vinay
can you
Suresh,
yes, sir. Vinay has some question. Yeah.
so that is the traffic load simulator, which will be simulate the vertical and horizontal loading. Yes, ma'am. Actually, we are doing with following with dynamic load with vertical load only, with 80 kilonewtons load, 800 kgs. This one, Mr. Vinay. We are using dynamic load in FWD. So Lakshminarayan sir, can you send it through mail, sir? I'll reply through mail your question. In India, yes, the sub-themam 3D is available from March 1st week, sir. Hello?
Yeah, sir. Here, Lakshmi Narayan sir has replied, sure,
Yeah.
sir. Thank you.
The equipment is available from March 1st week, ma'am. The sub-mm 3D instrument will be available from March 1st week next year, 2021.
Okay, sir. Fine.
I will reply to that question, Mr. Lakshminarayan. So Mr. Annie George is asking for the price. I will send through him a mail. He's asking the equipment cost. I will send you through mail to him. Mr. Annie George has sent. I will reply to mail, man. Whatever they're asking questions, I will send it. They're asking the cost and where we supplied. I will
Yeah,
share
sir.
you the details through mail to him. You can
Yeah, sir.
share
If
my
you
email
can,
ID.
means you can able to share your mail in the chat box also, sir, so that they
Yeah,
can.
I'll send.
Yeah.
Yeah, yeah, already forward, ma'am. Thank you.
Yeah, sir. Thank you, sir. Thank you very much, sir, for your
Thank you,
lecture.
ma'am. Thank you.
Thank you, sir. So, participants, feedback link has been posted in the chat box. So, kindly fill your feedback.
Thank you, sir.
Sir, thanks a lot, sir. Thanks a lot. This is Dr. Rajan. Thanks a lot, sir. Thank you, participants.
Thank you. Thank you, sir.
Thank
you,
you.
sir.
I'll be in touch with you, sir. Thank you.
Thank you. Thank you.
Thank you, sir.
So thank you all the participants. So it's a time for lunch break. So we will be meeting for the final session of the SCTP program at 2 p.m. by Mr. R. Prakash.
One important note, Mr. R. Prakash is a payment engineer, payment manager, I can say, in a very big private company at New Zealand. The talk is given from New Zealand, and he is going to talk about a very interesting case study which he has dealt in his company on related to material related issue on some what you call the payment maintenance or payment failure strategies, how the influence of material behavior or material quality, how it gets, what is the relevance of it with that failure or maintenance strategies or something like that. So it will be very interesting. He is going to present a case study. So I hope all of you will join by 2 p.m. Now we can break for lunch, and please fill the feedback links. And today we are informed not to share in the WhatsApp group because we want the participants to join the program and enjoy the session, get the knowledge, and then do the feedback process procedurally. So please don't post it in the WhatsApp as we did yesterday, Shivaraj and Shobana. Okay, thank you. Thanks, participants. You can take the link from this this forum as well as the YouTube forum. Okay, thank you.
Thank you, sir.
Break for lunch. Bye.
Thank you, sir. So we will be meeting for the third session of the day.